Okay, so in this video we are going to be going over the Advanced Dynamics test number 1. This test includes vector addition, and it also includes forces at an angle. Okay, and so we're going to start with question number 1, and this particular question is 1b. Of course, as we go through this test, you might have completely different questions in some cases, and obviously the numbers are going to be different for each individual person. Okay, so please just pay attention to the way I approach each problem. Okay, so this first question says, the three forces below act on an object. Sketch each of the three forces and qualitatively sketch the resultant between F1 and F3 using the tip-to-tail method. Now the vector F3 is this third one down here. Okay, it's mislabeled, but I gave instructions during the test that the third vector on here was meant to be F3. And then it says, then find the component form of each of the three forces and determine the magnitude and direction of the resultant by adding the three forces by components. So this is a 9-point question. Okay, and so just to get us started, I'm going to write down these vectors. We have F1 is 36 newtons, that's 70 degrees north of west. Okay, and so F1 is 36 newtons at 70 degrees north of west. F2 is 30 newtons, 48 degrees east of south. So 30 newtons at 38 degrees east of south. And then F3 is 68 newtons. And that is west. Okay, so let's start with the first part of the question. The first part of the question asks you to sketch each of the three vectors. Okay, so F1, 70 degrees north of west, would look something like this. Okay, where that is 70 degrees and the magnitude is 36. Okay, F2 is east of south. So the angle would be here, 38 degrees. The magnitude is 30 newtons. And then 68 newtons west would just be to the west. Okay, now, so you get a point for that. You're told to add F1 and F3 using the tip-to-tail method qualitatively. Okay, and so what that would look like, so with the tip-to-tail method, you start with one of the two vectors. It makes no difference which one. So let's start with F1 here. So let's say you have F1. You draw F1. I can do better than that, maybe. Maybe. So there's F1. And starting at the tip of F1, you draw your next vector. So here's F3. There's F1. There's F3. And the resultant would be like that. Okay, that's it. Okay, a lot of people, and in fact the vast majority of people, miss the point for the tip-to-tail resultant, because what a lot of people did is they found the resultant and then they wrote it with its components, and that's not what the question asks you to do. Okay, the question asks you to basically ignore the second vector, use the tip-to-tail method, and then go back and add all three vectors using the component method. Okay, so from here we're just using trig to find the vector component form of each of these three vectors. For F1, if you look at F1 going north of west, F1x would be 36 times cosine 70 degrees, but it would be negative because the x component would be negative. F1y would be 36 sine 70 degrees. F2x, looking at the picture, because it's east of south, we use sine to find the x component here. And so that would be 30 sine 38 degrees. And then F2y would be 30 cosine 38 degrees, but it would be negative because the y component is negative. Okay, and then of course the vector f3, we don't need trig to find that in component form. Okay, so just crunching the numbers really quickly, I can write down f3 right away. That's negative 68, comma 0. Okay, so then we have f1. Writing that in vector component form, I'm just doing these calculations over here. f1, we get negative 12.3, comma 33.8 newtons. And then f2, we end up with a positive x component, so that would be, let's see, 30 sine 38, which is 18.5, comma negative 23.6. You add up the x components with the x components and the y components with the y components to get the components of the resultant. So you do negative 12.3 plus 18.5 minus 68. That gets you negative 61.8, comma, you do 33.8 minus 23.6 plus 0. So you get positive 10.2. So here we have the components of the resultant. Okay, now to find the magnitude of the resultant, you just use the Pythagorean Theorem. Please do not put negative signs in when you're doing this calculation. I'm doing positive 61.8 squared plus positive 10.2 squared. Now, why do you not put the negative signs in? Because there's a possibility you're going to type it into the calculator wrong. I saw at least 3 or 4 people who on this test, they forgot to put parentheses around the negative, and they ended up getting the wrong answer. Okay, the negative sign does absolutely nothing for you. There's no reason you need to put it. It is technically correct to put it, but like it doesn't help you any more than doing it without the negative sign. Okay, so there's no point in doing it. You can only it can only hurt you if you make a mistake in the calculator. Okay, so this is what the magnitude would be. To find the direction, you want to sketch out the resultant. So looking at the resultant, I know we have a negative x component. Okay, so let's say the resultant is going in the negative x direction. It's going in the positive y direction. So based off of how I drew the resultant here, I know this is 10.2, this is 61.8, so this is FR. Here's my direction. So theta is going to be an angle that I can find using inverse tangent of 10.2 divided by 61.8. So I type that into my calculator, inverse tangent of 10.2 divided by 61.8, and I get 9.4 degrees. And that direction that I just chose is the north of west direction. Okay, so there's my magnitude, there's my direction, and I'm done with number 1. Okay, so basically for each piece that you missed, you lost a point. There are 9 points total on number 1. Okay, so pause there, make sure you understand how to do that. Okay, so moving on to the next question. Question number 2. Okay, so this one is question number 2C, and this is the longest, most difficult question on the whole test. In fact, if you were able to do every single one of these parts completely correctly, I would be very impressed with that. So we have Sam pushing a 24-kilogram shopping cart at the store as shown in the image below. Now, if you look at Sam's arms, notice that they are at an angle. Okay, you might not think about this, but when you're pushing a cart, because your arms are technically angled, okay, you're actually applying a force at an angle below the horizontal. So the question says he applies a force of 125 newtons directed at an angle of 30 degrees below the horizontal. And so what that means is his applied force, okay, if you think of what the FBD looks like, we have FG. If this is the horizontal, his applied force is at an angle 30 degrees below the horizontal. Okay, so there is the applied force. Then you have Fn going up, and you have FFK opposing that motion. Okay, so that's what the FBD should look like. To find the components of SEM's applied force, you just use trig. Okay, so the applied force has a magnitude of 125, so FAX would be 125 cosine 30 degrees, and FAY is going to be 125 times sine 30 degrees, but it is going to be negative because the y component of this applied force is going down. And so if I write that in vector component notation, which you didn't have to, but maybe helps you understand what's happening conceptually, you should get 108.3 comma negative 62.5 newtons, and that's your first point. Okay, so that is the answer for part A. Now, like any second law problem, you always start with your FBD, which we have. Then you write out your second law equations. Okay, so I have F net x equals MAX, F net y equals MAY. You determine if the object is accelerating, which it is in the x direction. Actually, I forgot what the mass is. Let me move up just a bit, 24 kilograms. Okay, so the mass is 24 kilograms. So that's 24ax. The object is not accelerating in the y direction because it is at rest in the y direction. So this right side is 0. And then step 3, you write down the sum of the forces before you plug in any numbers. So in the y direction, we have Fay plus Fg plus Fn. And in the x direction, we have Fax plus FFK. For B, we're asked to find the magnitude of the normal force acting on the cart. Once you have this setup done, you look over here and you say, oh, okay, I'm looking for Fn. So I need two things to find Fn. I need Fay, which I actually already found, and I need Fg, which I can find very easily because Fg is mg. So that would just be the mass, which is 24 times negative 10 meters per second squared. That would be negative 240 newtons. And so I have negative 62.5 plus negative 240 plus Fn equals 0. So Fn equals positive 302.5 newtons. Okay, that is your next 2 points. That is B. C says calculate the maximum value of static friction that can exist between the cart and the floor and thus determine whether or not this applied force is enough to make the cart move. Explain your answer. Okay, so you know that the force of static friction is less than or equal to μs times Fn. But the maximum value of static friction happens when this left side is equal to this right side. So FFS max is equal to μs times Fn, and μs here is 0.43, that's given in the question, and then Fn is 302.5. So you get 1 point for doing this calculation, 0.43 times 302.5, you get 130 newtons. Then you need to compare this value not to Fa, okay, but to Fax. Now, in this case, Fa and Fax are both less than 130, but what you want to do is you want to compare only the x component to FFS max, because FFS max is going in the x direction. And so the only force that's fighting against it is the x component of the applied force. Now, because 108.3 is less than 130, that means the cart is not going to be able to move. This applied force is not enough to overcome the force of static friction. Now, depending on what values you had, because everyone had different values, some people, the values came out so that the cart is able to move. Some people, it came out that it's not able to move. Okay, but that's why it's important that you show all of your work, because not everyone has the same answer to these questions. Okay, so that is C. Pause there if you need to look at that some more. Okay, D. Sam, in a burst of strength, increases his applied force to 364 newtons. Calculate the acceleration of the cart. Hint, the cart is definitely moving now. Alright, so I'm going to switch over to Notepad for just a second so I have more space. Now, the FPD is the exact same. I don't want to redraw it, but I do want to tell you that you have to recalculate some things. So FAY is now going to be 364 sine 30 degrees. And FAX is now going to be 364 cosine 30 degrees. And FAY is still technically negative because the direction is below the horizontal, so the y component is going to be negative. That's negative 182 newtons, and this is, let's see, 364 cosine 30, that's 315.2 newtons. Okay, now what we need to do, or what we're asked to do, is find the acceleration. But look at what happens. When we wrote down our F net y equation, we wrote this down. Okay, and this equation hasn't changed. Okay, this part is still correct. But because FAY has changed, Fn has also changed. So we have to find the new value for Fn. Okay, Fg is still negative 240, but Fn has now increased. Okay, so now Fn has increased to 442. And because Fn has increased, FFK has also increased. Because FFK, the force of kinetic friction, is the coefficient times the normal force. Okay, and the coefficient is given in the problem on my test, it's 0.18. Okay, so 0.18 times Fn, which is 422. Okay, so I'm going to calculate that. That has a magnitude of, let's call it 76 newtons. And so when I write down my F net x equation, my F net x equation still hasn't changed. It is still FFK plus FAX equals 24AX. I had that written down before. That just comes from Newton's second law. Okay, and then FFK is negative 76. Don't forget the minus sign because the direction is to the left in the negative x direction. And FAX is now positive 315.2. And so now it's just a matter of plugging this in and solving for the acceleration. Okay, so combine on the left, divide by 24, and I get negative, well, it rounds up here to negative 10 meters per second squared. Of course, your acceleration is going to be different. Okay, so that is the answer to D. That is a 3-point question. Okay, pause there. Make sure you understand that. Okay, E. Okay, E says, Sarah, Sam's bratty granddaughter, wants Sam to turn around and go back to the candy aisle. Okay, she walks up to the back of the cart and pushes the cart up and to the left at an angle 20 degrees above the horizontal with an applied force of 27 newtons. Assuming Sam is still pushing with the same applied force as in part D, determine the new acceleration of the cart. Hence, Sarah's pretty young, so despite her applied force, the cart keeps moving to the right. Okay, so we have Sarah pushing 27 degrees above the horizontal. Alright, so now my FBD has changed slightly. I have FG going down. I still have Sam's applied force. That is 30 degrees below the horizontal. I'm going to now call this F Sam. There's still an Fn. But now there is also F Sarah 20 degrees above the horizontal. And to top it all off, we also have FFK. So now, when I write my second law equations, F net x equals MAX, F net y equals MAY. The object is still at rest in the y direction, so this is 0, but now I have 4 y forces. I have F Sam y plus F Sarah y plus Fn plus Fg, all equal to 0. Okay, and so Fn is going to change again. And in the x direction, I now have F Sam x plus F Sarah x plus F K equals M. Actually, I know what the mass is. It's 24. 24AX. Okay, so I know what FSAM is because I had found that before. FSAM, I think, let me see. The X component was 315.2 and the Y component was 182, but it was negative. F Sarah, I can find the exact same way. F Sarah X would be, let's see, Sarah is pushing with an applied force of 27 degrees. Okay, so that would be 27 cosine 20 degrees, but she's pushing up and to the left. So because it's to the left, there is a negative sign there. So 27 cosine 20 is 25.4. Negative 20, sorry, 25.4 newtons. And then F Sarah Y would be positive 27 sine 20 degrees. 27 sine 20 is 9.2 newtons. Okay, so F Sarah, I'm only writing this for conciseness in vector component notation. Okay, so here's F Sam, here's F Sarah. I'm going to erase this part right here if you want to write that down. Okay, so I have F Sam, I have F Sarah, I have the components of all of those. Okay, so now my dominoes need to start falling. Okay, so what has Sarah done? By pushing up and to the left, she has changed Fn again. Okay, so I need to find the new value for Fn. F Sam Y is negative 182. F Sarah Y is 9.2. I don't know Fn, but Fg is still negative 240. These still all add to be 0, and so I need to find the new value for Fn. Okay, so 240 plus 182 minus 9.2 gives me 412.8 newtons. New Fn means new FFK. Okay, so that's mu k times Fn. By the way, as a general rule of thumb, you always should write down the equation before you start plugging numbers in, just to, just as part of showing your work. Okay, so that gives me 74.3 newtons is FFK, and now I can plug everything in here and get acceleration. F Sam X is going to be, I'll do it down here actually, is 315.2. F Sarah X is negative 25.4. Plus FFK is negative 74.3. And that is equal to 24AX. And so AX is, let's see, 315.2 minus 25.4 minus 74.3. And then divide by 24. That is, well, it rounds up to 9 meters per second squared. It's like 8.98, but of course you would have different values on yours. Okay, so that takes us through E. Please pause it there if you need to look at that. That is by far the hardest question on this test. Okay, and then finally F. Sarah gives up on pushing the cart, but does end up tossing an 11 kilogram salmon that she found in the soda aisle. I don't know why she found it in the soda aisle, but that sounds kind of sketchy. But she tosses it into the cart. Assuming Sam is still pushing with the same applied force as in part D, calculate the new acceleration of the cart. So, cart was 24 kilograms before, she tosses 11 kilogram salmon in the cart. There's a couple ways to think of that. Either you can think that there's like a new force in the cart, or you can just say, okay, the cart now has a mass of 11 plus 24, which is 35 kilograms. So Fn equals, so F net y equals MAY. We still have three forces in the y direction. The net force is still 0 because it's still at rest in the y direction. But now we have Fn plus F sam y, which we have been using before, plus Fg, but this Fg is not going to be the same as the normal Fg because now the mass is 35 kilograms. So now I have Fn plus, let's see, F sam y, I had that before, F sam y I believe was 182, or negative 182, plus Fg, if the mass is now 35 kilograms, that would be negative 350 for force of gravity. So I get a new normal force, and that gets me a new force of kinetic friction. Okay, so FFK is now equal to mu k, which is 0.18, times the new normal force, which is 532. Okay, so I multiply by 0.18, I get 95.8 newtons, and then my F net x equation has not changed. It is still the same, except now, so this is MAX, now the mass is 35. The sum of the forces, I still have F sam x plus FFK, and F sam x, probably should have written that down. F sam x was 315.2. So I have 315.2 plus negative 95.8 equals 35 AX. 315.2 minus 95.8, and then divide by 35, and I get AX equals 6.3 meters per second squared, and I am done with number 2. And if that seems like a lot, I would agree. On the other hand, there were 29 points on this test. You only needed 24 out of 29 to make 100, so it's not like you had to get every single point correct to make a good grade. Okay, pause there and make sure you get that. Okay, and then finally, question 3. We have a 11.6 kilogram box hangs suspended from 2 ropes as shown. Rope 2 makes an angle of 38 degrees between the rope and the vertical line shown. Okay, so A says draw an FBD for the situation. FBD should be very straightforward. You've got force of gravity going down. There's 2 ropes, so there's 2 tensions. I'm going to call this one FT1, and the other one would be FT2. It should go along the rope, but just my bad handwriting, I somehow missed drawing a line on top of a line, so just ignore that. But this other arrow should be like, parallel to the rope here, of course. And that's basically it. Okay, so that is 3A. Okay, B says write down both of your second law equations for this box. Okay, so when it says both, that means F net x and MAX, or F net x and F net y. Now, in both cases, the net force is 0 because the object is at rest, it's not moving. Okay, in the x direction, we have 2 forces. We have Ft2x plus Ft1. In the y direction, we have Ft2y plus Fg. That's it. Okay. So 1 point for the FBD, 2 points for these 2 second law equations. C says determine the y component of the tension in rope 2. Okay, so as long as you have these equations written down, this is easy. Ft2y obviously has to balance out with Fg, but if the mass is 11.6, then Fg is 11.6 times negative 10, which is negative 116 newtons. So that's Fg. That means Ft2y is 116 newtons. That's it for C. That's another point. D says, using your answer for C, calculate the tension in rope 2. Okay, let me redraw this picture so you can see what's happening a little bit better. Okay, so we now have ft2y. Okay, so we now have this component right here, this 116. We're asked to find basically the hypotenuse of this triangle, and then ft2x would be over here. Okay, so based off of this, I want the hypotenuse, I have the adjacent side, so I should be using cosine. So cosine of 38 degrees is equal to 116 divided by ft2, well, not ft2y, just ft2. And so if you rearrange that, you get ft2 equals 116 divided by cosine 38 degrees. 116 divided by cosine 38 degrees, I get 147.2 newtons. Okay, that is the answer for D. And then E asks you to find the tension in rope number 1. Once you have Ft2, if you look up here at your second law equations, notice Ft1 is balanced out by Ft2x. Okay, so if I take this and I multiply by sine, I will get the x component of Ft2, and that will give me Ft1 as well. Okay, so Ft2x would be 147.2 times sine of 38 degrees. 147.2 sine 38. That gets me 90.6 newtons. And so 90.6 newtons plus Ft1 equals 0. So Ft1 is negative 90.6 newtons. So I tried to lay that problem out in a way that as long as you did everything I told you to do, it kind of led you down the correct path. Okay, so that is it for this first advanced dynamics test. One more thing I will tell you about the grading. I believe that you needed 24 points out of 29 to make 100, and I also believe you need 12 points to pass. Okay, 12 points to make 70. Okay, the first question was very similar to questions we had done before. The format was the exact same, so you should have completely been ready for that and at least gotten most of the questions on number 1. Okay, and then you still have to get at least a couple from question 2 or question 3 with forces at an angle. Alright, please let me know if you have any questions, but you should now be prepared to take the retest. Over this test, remember, the retest is going to be the portion of my semester exam which covers this topic. Okay, so please let me know if you have any questions.